a moment for Twitch. All right, I've got a pretty picture over there. Oh, the camera doesn't like it when I hide behind that monitor. All right, I think we're there. The last question, do the slides work? No. Cool. That is why you expect OBS to always fail. Bam.
Yeah, but it also says here that demo that
Sure. Beautiful. Sure. Do it.
We're
There. We're there. Mash this. Mash this and this. Twitch says, all right, cool. Things are working. So, aside from that camera dying, gosh, dang it, OBS. Oh, it's because I blew away the wrong thing. Bam, bam, bam. Bam, bam. Let's make sure this doesn't do anything. Sweet.
This is talk. Now this is like forced update to sound if you're on something.
All right. Sweet. All right. Today is the 18th of September. We're week 5 here at CSE466, and we are hopefully wrapping up the topic of reverse engineering. But from the chatter I heard before class, that may not be the case for all of you. Means Yancode is kind of a famous challenge in this course. It is a blind reverse would be the best way to kind of explain it. This isn't a secret. The challenge tells you what's going on. The encoding of the instructions is randomized at runtime based upon the flag. What that means is you have no idea what bytes mean what things in the Yancode VM. And instead of, so you can't like throw GDB on it, you can't throw IDA at it, know this, you have to figure it out through clever observation of behavior. You're like quasi-fuzzing this thing. And one of the first steps is to try and get this challenge to call exit A, which then gives you a tiny piece of information. You build up from there, and eventually you can write all of the VM Yancode that you need. But it's a very challenging, it's a good culminating challenge. There's a case to be made that cows and bulls should have been before the Yon 85 stuff, because this is certainly not easy. People are getting to some of the later Yancode stuff, which is not only Yancode, but Yanalyzer, which, if I remember right, is this challenge asks you to pass Yancode bytes to it to run it. So you have to not only understand how the Yancode VM works, but be able to generate Yancode bytes, which is its own kind of sub-problem. Now, how you reason about Yancode is entirely up to you. A lot of the live streams that you've seen is us kind of poking around in IDA. Hopefully I can avoid that today. We'll see. If you don't want to rename things, it isn't a bad idea to take notes and just note how you think this thing works instead of trying to rename everything in IDA every challenge, because that is tedious. In case you're unaware and you use SSH, you do now need to SSH to a slightly different address. This is for technical reasons, because somebody decided to try and DDoS us earlier this week, which was amusing. Instead of SSH to pwn.college, please SSH to dojo.pwn.college. There's a couple things that are still slightly misbehaving as a side effect of this. If there is something that is causing you grief, please let us know. We'll take a look at it. Logistical things. The route module launches tomorrow evening. There's not going to be a ton of changes there from what's existing, so that's a good thing, hopefully. I have something conflicting with my office hours on Saturday. Now, I can either make it up tomorrow or make it up to you on Sunday. I have a feeling you guys would feel Sunday's the better day, since that's the due date. Yeah. All right, so all of my office hours Sunday still 2 to 4. They just won't be on Saturday because I have a conflicting thing. So people asked about the course schedule, because we did give you an extra week for this first module. The syllabus schedule is still out of date. I haven't fixed that. The kind of rough What has happened is everything got pushed back a week from what's currently on the syllabus. I don't want to update the syllabus plan schedule until I have it all sorted out. The midterm exam will still happen as planned. I looked at how that kind of lines up with everything being pushed back a week. It still lines up perfectly fine. So it's still tentatively the 21st and the 23rd. People are having questions about that. Grades. So we did finish up program security, not talking about Rev. We did get a little bit of time to look at how we all did. So on average, across, I think, 54 students, the average student solved 65% of challenges, which means that you did get past that checkpoint, which is good, partly because the checkpoint was the same as the due date. 32% of the class solved every challenge that was on there. It's worth noting when you see that number that there are people who are working ahead and started working on this class over the summer. And so those people are included in this number. Don't let that intimidate you. The average module grade, including the checkpoint, is a 72.1. So what's that? Just over the cusp there. This isn't including any extra credit. And then as far as quartiles, if you were to chop up the class, over a quarter people got 100%. Right, it's 32% there. And then the bottom quartile was 41% or lower. The thing that's nice to see here is at least half the class scored about an 80. That's with the checkpoint. And so by and large, this is in line with kind of what we expect. The average here is going to be calculated slightly differently than future averages, since this is the first, generally speaking, what we do when we compute like class grades and like how we did on the module is we throw out students that don't solve anything because we just assume you decided to check out, you haven't dropped. Which is totally fair. There's students that will stay registered with the course but not solve anything. Right now, those people are included, which means that these averages and numbers are slightly lower than what I would consider reality, the people that are actually working on the course. If you like graphs, here's the distribution of challenge solves. You do see a strong bias towards the 100%, and then everyone else is kind of even in between. It's not a normal distribution, but it's also not a module where we're all starting off at the same place. The scary thing, or like the thing to be concerned about, is this right here. Remember, getting to one side of that 50% mark is a big difference than being on the other. Yes?
What's it? Does this include the people who dropped, or
this does not include the people who dropped? So I want to say that this is 54 people who are roughly registered from the original 132 that we started with. Yeah, like if you dropped, I don't care. You're not in the class, right? Why?
yeah, it's like that's not a lot of data.
No, that is 50 some odd data points. That is everyone that is in this class. I can only tell you the data that's there. But the concerning thing is again, this right here, these people that were just below that halfway mark, that checkpoint makes a big difference on which way your grade swings, which you see right here. Once we account for that checkpoint and look at the grade of the module itself, people are either on the left-hand side or the right-hand side, which is the kind of determining factor you see is that checkpoint. Another thing we like to look at is cumulative solves over time. So this is just kind of the progression of how people moved through the material up until the checkpoint and deadline, which was the same thing for program security. Zooming in a little bit, this is like the last 48 hours where we can see where people push. It's not super interesting here, to be honest, but it is worth comparing that to, for instance, reverse engineering, the module that we're doing now, where the checkpoint and the deadline are two different things. If you look at just the slope of this, right, this is what we're doing for this module, and this is what happened for the first one. We see that people are starting earlier. What's the word I'm looking for? That's a word. The slope. That's the word I want. The slope of the line for reverse engineering is steeper, implying that people are starting earlier, which is ultimately what we will learn the hard way through this whole semester. All right, that's all I got for slides. Any questions about any of that stuff? Cool. Demo plans. I didn't build a canned demo, so it's up to you. What do you want to see? I saw some discussions about creating an assembler with Yan85, and people are not creating assemblers, people are creating emulators, which is way more work than needed. So we could certainly go down a path here and be like, hey, let's create a Yan85 assembler. It is worth it right now, I'll tell you, to truly understand Yan85, because Yan85 is not just in the Rev module, it is in the program security module, it is in the system security module, it's in the microarchitectural module. It is a reoccurring theme. So the more time that you spend on it now, the easier that'll be later when there's other stuff that you're supposed to be figuring out. Alternatively, what I can do is one of my favorite demos. I don't know that I'll be able to replicate it, but I will show how we can leverage GDB and GDB scripting to essentially turn one of the Yan85 walkthrough levels, or I'm sorry, hard levels, into an easy level, right? The easy levels have that nice printout where they say, you know, STM, IMM, whatever. Using GDB scripting, we can run one of the hard levels, read and produce all of that same output, which I think is super cool. It is not something that I see a lot of people do, but I like GDB much more than IDA, and so it is a cool way to show kind of the power of GDB if you want to see that. Otherwise, hit me and we'll do it. Any preferences at all? No preference. Did everyone solve everything here? Like, something has to be more useful for one of you.
I don't know what's more useful or not useful. I'm just stuck.
Okay, well, what are we stuck on?
Yan85.
We're stuck on Yan85, right? And this is,
What if I don't want the GDB script?
if you don't want the GDB scripting, we'll start with the poor man's assembler and go from there.
Yeah,
What's that?
we kick him out.
We can kick him out.
Yeah.
You're
No,
not.
it's okay. It's okay. Like Michael's a big fan of IDA. IDA's a great tool. A lot of people like, you know, hitting tab on IDA and thinking that that's the answer to everything. I'm not going to convert you today all to love GDB, but by the end of the semester, you will. Yeah, you just learn the hard way over time. So where are we? I think we're on, is it this one?
That's a good one.
Yes.
Or I'm trying to figure out, no, it's this one. It's Yancode that I'm thinking. I don't really care which one it is. It just needs to be one that takes in
Yeah.
Yancode bytes. Yeah. Again, I can't do pwn.college. This will just hang. I need to do dojo.pwn.college. Can you alias SSH?
Like I want it to be when I type hacker at pwn.college. Right?
So what you can do, I don't want to show mine in particular live here on stream, but inside your home directory of your local computer, you can create a .ssh folder. One of the files that you can create inside .ssh is a config. This config file, you can give various hosts shorthand names. So like if I want to SSH into the backend of the dojo, I can just do SSH dojo. And that is mapped to an entry in this config file where it knows the address to resolve, how I want to SSH, do I want to like forward my crypto, etc. Right? You certainly can do that. I don't have a config for this specifically so that anyone watching the stream or the YouTube video later can replicate what I do. Right? If I had some shortcut for it, that would be kind of a troll. Somebody says, show us cows and bulls. You are a troll. Don't tell me that. I know who you are. Okay. So if we take a look at this challenge here, this one is a little bit different. This one says, now you are in control. Please input your Yancode. I give it something. It then tries to interpret my input as Yancode bytes. So what I need to do now is I need to somehow figure out what bytes I need to pass in to write my own Yancode. That's a face you've got there. So one of the things that you should hopefully learn as part of this course is using programming as a tool to help you do things, right? I could open this up in IDA, and we can do that. We hit tab, we have mastered IDA, all right? I then find, hopefully at this point, you have some idea of the function names that you're looking for. One of them is like interpret instruction or something. There it is. All right. Hopefully at this point, you've seen this pattern of there being like some type of function, and then it is conditionally executing one sub-function here based upon some encoding. Have we gone that far with it? Yeah. So we can look at this logic here, and I can say, all right, interpret add for this particular challenge, which yours will be encoded differently, is hex 40, right? Hex 40 encodes to interpret add. And we could envision that there is some mapping from these Yancode actions, like immediate add, something with stat, STM. This was a question on the Discord. Did anyone figure out what the M stands for? Memory, right? So the action of storing the memory, loading the memory. And so we have these like concrete things that we know we can do in Yan 85. What is an assembler? Like in the most simple caveman word, what does an assembler do?
Turn a machine code into assembly.
Yeah, it turns my English, right, my programmatic move RAX 20 into assembly bytes, into machine code bytes. So an assembler at its like simplest level is just a mapping of some high level representation that's easy for people to understand to bytes that the machine understands. And so if I want to try and tackle this challenge where I need to pass it bytes, it might be useful for me to create the simplest form of assembler, so that way I can reason about what I'm doing. And this will pay off in later challenges as well. So it's not just a one-off for this challenge. All right. What is one way that we can create a mapping of a key to a value?
Dictionary.
We can use a dictionary. Perfect. So my assembler is going to consist of like 2 or 3 dictionaries. And that's really it. That's all we need to do this. So I'm going to have some mapping, call it like instructional mapping. It's going to be a dictionary. What I want here is, what do I have? IMM. And that's going to map to what byte value? Looks like 2. I'm going to have add, that's going to map to 40. So what are the things that came up on the Discord when we were looking at IDA was like trusting IDA's typing and things like that, right? And one of the questions that came up was like, hey, what happens if I need to move, I think it was hex 116 into memory. I think we were using STM. How big is the memory space of Yan 85? Has anyone figured that out?
256.
256, right. What is unique about 256? Like, why that number? Did we just like 256 is a cool number? That's how much memory you get? It is a power of 2. More than that.
60.
It is what the largest space you can represent with a byte. A byte goes from 0 to 255. There's 256 memory addresses. Everything in Yan 85 works on bytes. So if I add 2 numbers, if I add 255 plus 1, the addition would roll over. But the unit that we're working with Like the largest addressable unit in Yan85 is a byte. And so every write that we do is just a byte. Every instruction that we do is a set of 3 bytes, where there is a byte for an instruction, there is a byte for R1, there's a byte for R2. So what was my second guy here? I think do STM, which, what was I doing? Add? Sweet. And this one was, I'm claiming 40. And the reason for that is IDA doesn't know. IDA is representing this as a number. We aren't flipping this, so I have to look at how many bytes are here. We're ANDing this. And A2 here, IDA thinks is a 64-bit int, right? Which is why is this showing up as 3 bytes? Anyone?
It was bit shifted.
Someone says it was bit shifted. Is that true?
I think before it starts interpret loop, it gets bit shifted by like 16.
All right, let's I put my cursor on there, hit X, I'm looking at where the call site is. I'm looking for the second argument. In this case, it's whatever this is. I don't see a bit shift.
Maybe not this.
No, there may be other challenges where there is like a bit shift going on. But what is a Yan 85 instruction? How many bytes is a Yan 85 instruction?
3.
3. Okay. I mentioned on the Discord that your level, whatever this is, Yancraft Easy and my Yancraft Easy are going to be different. So if you opened up mine in IDA and yours in IDA, and we go to interpret instruction, odds are reasonably good that you may not have this exact same pattern. Because one of the things that's randomized is the order of those 3 bytes, right? There's an instruction byte, there's an arg1 byte, there's an arg2 byte. Maybe mine is arg1, arg2, then action, I guess I'll call it. What did we call this? Interpret instruction? Okay, instruction. IDA doesn't know that I'm looking at this as 3 bytes, but the byte that is determining the instruction that is being executed on this VM is not the first byte, not the second byte, but the 3rd byte. Yours may look different. You may have hex 4 here. If the byte that was determining what instruction was being executed, if IDA thought this was 4, is that the least significant byte, the second most least significant byte, or the third most least significant byte? It would be the least significant byte, because IDA isn't that smart. IDA just says, I don't know, man, here's some bytes, it looks like a number, right? We have to apply our reasoning of how this thing is utilizing these bytes. And then this is kind of the trap when people say, I'm looking at this, and like if someone could tell me what's going on, then I would get it. What the act of reverse engineering is looking at code that not only did you not write, but is like malformed because it came out of a decompiler, and trying to make sense of it. So I learned something else from this right here, just this line right here, that's critical for my assembly. And that is, I know that the 3rd least significant byte is what determines my instruction. So I'm going to have some order value. I'm going to say, I don't know, 1, 2, 3. Okay. And we'll imply, I'll add a note for myself, instruction, arg1, arg2. And that is what 1, 2, 3 would mean. In this case, I know that my 3rd byte is actually the instruction, right? And so I need to encode that information in my assembler. All right. We had add, which we said is 8.
I think
add was not 8. I can't read. Add was 40. It's worth noting this is hex 40, not real 40. Okay. Now, the other thing I need to figure out is this, I I know that the instruction byte is my third byte. Do I know that R1 comes before R2 or R2 comes before R1 for this? I don't, right? How can I figure that out? Something on line 14. Okay, we could use the print output of the challenge. Do you think there's a hard version that doesn't give you that?
Yeah.
Okay, so that may work for the easy one, but let's assume that we don't have this printout. How else could I figure that?
We dig into one of the functions and find out what they're adding in.
Okay, so I could dig into one of the functions and see what I'm adding it with. So if we look at, for instance, let's do immediate. Boom. We now have rate register the high byte of A2, followed by, what would this be? Is this the low byte?
Yeah.
Why?
It's an int of 8 bytes, 8 bits.
These are both referring to the same memory location, right? And what we need to think about it as is, okay, there's a series of 3 bytes. If we say this is an int 8, I'm only looking at the first 8 bits. That's the least significant byte. High byte, if we were to IDA it, is, I almost guarantee you, going to be the next 8 bytes. And so what we really have here is arg1 is which of these? arg1 is my second byte. Write register, first argument is the high byte, which is going to be the second byte. So it would be, see if I get that right. No. 3, 2, 1. It's actually completely reversed. All right. I'm going to pretend it is. We'll find out if I'm wrong. All right. So I have this mapping. How do I use my assembler? All right, we'll have def main. What I want to be able to do is say my Yancode string is immediate A2, immediate B forward, and AB. I wanted to be able to do something like this. This is the goal of my assembly, is I want to be able to write stuff that looks like this, and I want the code to translate it into the magic bytes. This is what an assembler does. How do I parse this string?
Break it by line first, and then for each line, split it by the bases.
Okay. I'm going to have some parse function that's going to take Yancode string. I need to split the Yancode string. This is going to split on new lines. For line in lines, I'm going to split on a space. This would be words. Okay. How do I turn the, so if I looked at, for instance, words 0, what would I get? Assuming I can write code, we'll find out. Right, I should get IMM. Let's verify that. It's hot in this room today.
Shouldn't be for the first line of part, this was split by like the last n or something, or no, not the second.
Help to write valid code. I got nothing. Okay.
You don't call me.
Oh, yeah. If name equals main. Main. This is just a Pythonism. Okay, split's not defined. Why is split not defined? That's because lines needs to be Yancode string dot split. Is that what you were correcting me on?
Hmm.
Yeah.
That's right. And you have to split on. Okay.
I could define that I want to split on new lines at the default value. And so now we see that I'm getting these values. Okay. So four line lines. Words. What I want to do is I want to take my instruction mapping and I want to take the IMM, pass it as a key to this dictionary, and get the value out of the other side, right? That's going to be the byte value for this instruction. You agree? Cool. So then, what is that? Words 0. And this is going to be the instruction byte. arg1. I'm going to assume when I write my Yancode that arg1 is the first thing and arg2 is the second thing, right? Let the assembler deal with whatever weird flippy floppy stuff is going on, which I probably have wrong, but we'll fix. arg1 is going to be, right now I have it as a register, but how does my assembler know what A is? I don't, right? So I need a new map, right? I need a new dictionary. So I need a register mapping. I'm going to have things like A and B. How can I find these mappings in my Yancode? Has anyone delved in here and figured that out? That's not in the help text.
Describe register.
Okay, describe register is great, but isn't describe register, is that help text or is it a built-in? You can rely on help text, but that's not going to help you as soon as you go to the next challenge. There was a funky face there. Let's sanity check why I would not use describe register. If we look at this one here is Yancraft easy. There is a Yancraft hard. If you've done any of these, the easy one prints out nice stuff. The hard ones do not, which means the hard one will not have describe register. Where else can I get this register mapping?
Inside right register.
I'm sorry?
Inside right register.
Inside right register. Okay. Again, we have a similar pattern of some type of switch or if where we're matching a value to a location in memory. Now, one of the things that you might have noticed about how this Yancode VM works is these memory locations correspond to specific registers in the Yan 85 VM. I believe this first one is register A, and the second one here is B. So that means that A is 2, B is 64.
This one will be around.
Do the memory locations
No, I don't
use
think that.
as registers?
No, as like the first one is always A, the second one is always B, or is it like first just for fun they go like first one is B, second one is I, the last one is A.
So I don't want to like say this with 100% certainty, but I'm pretty sure. Just as a like implementation detail, 1024, that offset will always be registered. I don't know that that's the case, but I'm pretty sure as I think about how that works.
What we could do is look at the exit or this is called instruction and look into that. Like which there, what is the memory location? We can be sure that that's the register A.
Yes. So another comment from the class was specifically if we look like how interpret sys works. Interpret sys specifically uses I think register A for something. And so you could know that that is register A based upon how the interpret sys function is utilizing that memory location. So
Yeah.
where are you going? Yeah. Let me take a look here at Twitch real quick. Reasoning's hard. Troll. Yeah, nothing super important. Cool. So now I have this register mapping. Now, I'm assuming right now that arg1 is a register. What else could arg1 be? Literal, right? It could be 2. It could be 5. right? Because I'm doing this generically. So I need to somehow parse, reg, or literal. I'm making this up as I go, so we'll find out. Of words 1. Cool. So I'm going to from string import, is it ASCII lowercase? I think is what I want. Is that right? From string import prim from pro. Every once in a while I get it. So ASCII lowercase is just a string of every lowercase letter. You could imagine that you write this yourself. I'm just saving myself the headache. And I'm going to say if val is in ASCII lowercase, right? If it's some letter, then I'm going to assume that's a register encoding. I could say A, B, C, D, whatever. I'm making this up. It's hack code, not production quality. Then I want to return register mapping of val. Else, return val, or return int of val. Except int is going to be a number, and what I really want is a byte, and I have this problem already. But I'm not dealing with it yet, so let's just keep everything as no. Okay, arg2 is going to be the same thing, except I'm dealing with the next value. Everything makes sense so far? We're just writing some human understandable stuff, mapping it to some byte values that we're getting out of the VM. Then I have my instruction byte, my arg1, my arg2. Now how, Sammy, you're a clever person.
You could do a
How do I make this order map to what I'm doing?
Well, right now you're not saving the registers or anything in an array.
Right now they're not in an array. So I should store them in an array and then use these as indexes and decrement it by 1. And so instead of 3, 2, you're clever. Sammy, I knew you'd get me there, Sammy. So I could do something like this, which is the order that I want to access them, right? So this is an access order index, right? And so we'll say the Yancode or string vowels is going to be instruction byte, arg1, arg2. And I can do this, right? Byte 4. No. Bytes. Yes. And then there's, what's the length? More buffer bytes int. Is it? I think the second argument is just length. Encoding. I swear there's a length argument to this thing.
Which passing element?
Isn't there? Oh wait, I'm a goober. I can just Pwn Tools P60 or P8. I'm trying to turn a number into a byte.
You could do
P8 will do what I want. I was using bytes, the built-in, and there's some flag you can pass to specify the length, but I don't remember it off the top of my head. Okay, so all of these, I don't want these to just be numbers. I want these to be bytes. So we're going to wrap all of these in P8. Cool. Now I have an array of bytes. Now my output here needs to be string vals or for index in, what did I call this thing? Order. Let's name it something a little bit cleaner. Byte order. Let's print string vals index. All right, that's what I want. Vals index. Let's up here in parse. We'll have some output. Output append the byte of the index. So what I'm doing here is I have an empty list. I'm using that byte order value to determine how I'm mapping this into what the Yancode VM is actually doing. I'm probably doing it wrong. That's honestly okay. We'll discover that together. But that's my logic. So now this is going to have this output list. And we will return output from this parse function. Cool. Let's write this. Let's not separate concerns. From pwn import star. Let's just throw this into the challenge and see what happens. P equals process. Challenge. What do I got? Yancraft easy. P.send output P interactive. All right, if I did this right, which I'm sure I didn't, as I run this, this is the byte string that is the result of assembling these Yancode instructions. Right? I then go, once I have those bytes, I'm going to pass them into the challenge. And what I'm doing right now is I'm just sanity checking myself. Because this is an easy one, it's going to print out what it thinks the Yancode is. And it should look like this. That's a horrible name for a file. Words 1. Okay, what did I do wrong there? Split n words. Right. 4 line in lines, line dot split on space. You're good. 4 line in lines.
I think the issue is with this or split function. Like right now, it's splitting on any space.
Oh. All right.
Yeah.
Okay, so we're almost there. Inst mapping words 0. It is grumpy because. Why is it grumpy? In parse, inst bytes, inst mapping. P8 inst mapping 0. We're just gonna print debug this because why not? We got an empty string. Okay. We'll say if not words, continue. The empty string should be falsy. We still get nothing. Okay, we got problems. And my lines looks good. That is because of the empty string. So like if not line continue. Immediate A2. Okay, that's a good line. What's up?
I think we got one.
We got one. Making some progress, yeah.
Then because it's splitting the tab into spaces.
Maybe. So then I still want to print line.
You don't want to print work, so let's see how.
Oh, okay. At that point, I can split on all white space, right? And that should eat the tabs. There we go. All right, almost there. P8 int mapping words 0. What is words? Words at that point is this nonsense here, which is nothing, right? I'm splitting that.
If not words, exit.
No, I don't want to exit. So my problem here is I got rid of the empty string at the beginning by if not words, right? My problem I have right now, and this is we're just programming, we're not even like doing cool cybersecurity stuff now. Is this line right here? I don't know what it is.
We remove that line from Yancode string itself. Like we put the 3 double quotes at the end of the instead of a new line.
Oh, you want this? That is so ugly. All right. List object has no attribute encode. Where am I? In packing, need bytes, p send output. What is my output?
Upload the list.
Oh, okay. If output is a list of bytes, then I really want to return this. Take an empty byte string and then we'll join all of the bytes that are in the list of bytes. Woo! All right, we got something going on. Okay. Did I get things right? So this is, and if you didn't see what I just did there, boop. I ran my assembly file, which has p interactive, but it's running forever. I just pipe that into head, which is a shell command. It'll give me like the first 40 lines because I don't want it to run on forever. I'm really interested in what's happening at the beginning of this thing. If we look at the beginning of it, I got immediate A2, immediate B4. Okay, it turns out I did do some of it right. So we got these instructions encoded correctly from my human understanding to what this VM is thinking. And then I wanted add AB, which I don't know that's even how add works. I did get it. Cool. I'm feeling pretty good about that now. All right, a little bit of cleanup. Good. Right. And so now what I've done is I've kind of built this generic mapping guy. And you could envision that I or you write more of these, right? Fill out the rest of the instruction mappings, fill out the rest of the register mappings. One of the things that you will also have to deal with that I did not right here. There's going to be some mapping for syscalls, right? Any of the things that are dynamic across the challenges, the instruction order, the mappings or encodings of instructions to bytes, and the mapping of encoding to syscalls. You'll want to abstract that into some type of mapping that the rest of your logic uses, just like this. Does this make sense as a approach for kind of getting started on how do I do this, right? How do I deal with getting Yancode bytes into this machine? Because if you don't, right, and I've seen people do this, what you end up doing is people are like, oh, I'm going to echo the byte 4, right? 4, 3, 1 into this challenge. Right? Turns out that was completely invalid. But you could do, what's that?
You need the previous.
Oh, yeah. All right, cool. It turned into some encoding, right? And people will just try and like yeet bytes into this thing and be like, okay, well, maybe I need to change this and tweak this, and you start working at it at this level. The problem with doing this is that you can do it this way and like solve a challenge, but you're not increasing your productivity for the next challenge that's going to ask you to do this. And so the sooner that you build something that looks similar to this, the sooner you are writing Yancode that's like this. I don't know that that's a valid instruction, right? But it's once you have the mappings all configured, when I'm trying to reason about what I'm executing in Yancode, I'm now writing in this higher level abstraction. And the purpose of your reverse engineering is to just yoink out these key values, which removes a lot of the headache because you've automated a lot of this. So hopefully that's useful for anyone that's tackling that. Some people do solve it like that. Yes, people will echo random stuff in there. Hello from Twitch. The rest is all troll bait. Anyone have anything else you want me to talk about? There's some challenge you said was like a good challenge. You want me to poke at that? No, you've solved it. You've mastered it.
Low key, I got so much insightful information right now.
Yeah.
Yes.
Inside.
See, in my mind, I'm just like, I just spoiled so much of this challenge because the act of reverse engineering, which is why this is a painful thing for people to go through, is looking at this and reasoning about how this thing works, right? And that's why when people ask questions like, what is, let's see, interpret instruction. Let's find another one. Where's a crazy instruction? STK. Okay. What is STK? Right? I shouldn't answer that. The answer should be, well, double click on this, read it, and figure it out, right? It is not literally push, right? You have to read the decom and try to understand what's going on. And one of the reasons that it's useful to spend time like right here, right now in easy mode is because what happens when we fire this up in hard mode? Or get the hard version of it. I love how this window is. Main. All right, there's our friendly language. We're going to go into this sub thing. Now I have this. Well, this isn't super easy to understand, but I may have seen this before. Does anyone, since you spent time in easy, does anyone want to tell me what this function is? Interpret instruction, somebody said. Right. I don't need to go here and click on sub whatever and name this interpret instruction 50,000 times. Once you have the mental model in your head, you should of how this program works. We're spending time on the easy version. Apply what you've learned when you're looking at the crazy decomp here. I have this pattern. These are some byte values. This is something else. Now, I don't know what this is, right? Is this, I don't know, immediate? Is this interpret sys? Is this, I don't know. How do we find out? All right, we give it the old double click. That's not very useful. I'll give it another double click. Okay. So it's doing something with registers. What information does this function have? The mapping of registers to numbers. right? Which is useful for me when I'm writing my assembler right here. This is a section where I want to apply the mappings that I see here in this switch to my assembler logic right here. So it's doing something with registers. Did I get lost? Go back. This is returning the return value of this. A1. Okay. I know what this is. Anyone want to tell me what it is?
Right.
Right register. How did you deduce that? This is just clown town.
By like keeping track of the arguments.
Okay.
See, it's storing at the register also. So.
Right. When we looked at the easy version, I made this statement that I believe this is A, right? I don't know that this is the memory address that represents A, but I'm pretty sure. But the observation that was made here was what is happening when we go into this function is it's taking one of the arguments and it is writing it to a memory address that we saw, or a memory location that we've reasoned is a register, then breed. And so this, is that actually what it's called, right register? Wait, no, it's IMM, isn't it? Immediate A2, that's how we put a constant in a register? No, it's good. I would have gone with right register as well. I just realized. Right, call it whatever makes sense to you.
Yeah.
But I just got to try and be consistent from making what we saw earlier. So now I know, but I may have to rename a few of these things. I know immediate is for this hard challenge is the encoding 4. What else do I know? Why is this 4 and not hex 00004? Talked about it earlier.
Because it's not doing first.
What's that?
You get the order.
It's doing the order's different now. It's it's comparing the lowest byte instead of the highest.
Great. One of the things that I said was randomized was the order, right, across these challenges. IDA doesn't know that these are 3-byte things, but IDA knows that the only byte that matters for this conditional is the lowest, right? The least significant byte, which is why IDA's just like, yeah, this is just the number 4 or the number 1. And so we can't just blindly trust IDA on these things. We have to apply our own understanding of how the program works to what IDA is output. All right, so you can envision that I double click and rename all this, and it's a jolly good time. All right, any questions, comments, concerns, things you have? I got 15 minutes, give or take, and 0 plans. You solved everything? You're good? I love it. Yes.
How long would that GDB thing take?
The GDB thing is a journey. All right. It is an educational journey that could take 3 hours. We can see what we can bang out in 10, 15 minutes.
Let's continue it on Tuesday.
Continue it on Tuesday? I could not, because what are we doing tomorrow? We're launching Raw.
Oh, yeah.
At which point, in class at least, we're done talking about reverse engineering, right? The deadline for the reverse engineering challenges is this Sunday at midnight. That's not moving. It is good luck, right? Get it done. Hopefully you start it early, or try and get your on for office hours on Sunday as long as you can. We'll see what happens there. Let's do. I'm gonna do the analyzer.
Yeah.
15 minutes. All right. Does this one? What does this thing want? This thing wants a key, and then it just says incorrect. Did I run easy or hard? It's grumpy at me.
You run hard.
Yeah, no, I'm going to run the hard one. I just want to show something here real quick. Cool. So when I run this, the easy ones have this like super helpful output, right? Where it is telling me what the high level like representation of the Yancode instructions are. It's also showing me the register values, right? These exist somewhere in memory in this program, right? In fact, we looked at them in IDA a little bit. I keep claiming A is at some offset of like 1024 or something, right? You can use dynamic analysis to take the hard version of this challenge and output stuff that looks like this with GDB script. Did you know that? Super cool. Let's see if Twitch had anything real quick. Twitch says nothing. All right. So what I want to do is remove whatever do.py was, make a new do.py. User bin n python 3 from pwn import star p equals process, whatever this challenge is. P interact. Cool. Now, if I want to use GDB instead of P interactive, we can use GDB debug. All right, you've seen this pattern before. Beautiful. Where am I? In addition to like being painful in IDA, where everything is named sub whatever, strict binaries are pained in GDB, right? I'm at underscore start. Can I break it main? Oh. So we got problems. Did anyone by chance watch my very, very long stream last week, Thursday? We have a strategy to deal with this and reason about where functions are located in memory for a script binder. I think Michael showed Jeff's like PIE break, PIE run, that type of thing. I don't know. That's all magic to me.
Lives?
What's that?
So the lives thing?
Is it the yes? The statement from the class was, is it the base thing? So one of the things that you can do is you can define a constant in your .gdb init. I call mine base. It is this hard-coded number. This number is not arbitrary. It turns out if you run a binary and you tell pwn tools you want it to not be set UID, you want ASLR to be disabled, and ASLR equals false. A, B. If we take a look at the base address, it is going to be this fixed constant, this 55554000. This is the base address of where the binary is loaded into memory. We can use this information with IDA to reason about where functions are located. IDA thinks it knows where main is. And honestly, GDB should know where main is as well, but it doesn't. So if I put my cursor here on main and this window cooperates, what we should see, there's this hex number down here. Does anyone know what this hex number here is? It says 1C F4, and as I move my cursor, it kind of changes. Right, that's the offset from base. So here, the beginning of main is at 1C D8. So if I want to break at main, even though GDB doesn't know where main is, I could say break at main plus OX 1C D8. Then I'll say continue. This continue is because I don't care about being at underscore start. I'm sorry?
Base.
Somebody says, do I mean base? The answer is yes. If I do that, if math works, that did not work. Base plus, oh, I need the star. Boop. Cool. I claim I'm at the beginning of main now. I'm definitely in, I'm going to say main, because libc start main calls main. And so this stack frame is main. We also see that the first argument to libc start main is the pointer to the main function. So I have now been able to set a breakpoint in this strip binary at a location of interest, despite the fact I don't have the name. But I really don't want to be in main if I want to try and do some cool stuff in the next, like, 4 minutes. Instead, oh, this challenge is lame. What are you doing here? But I'm looking for something like this. Anyone want to tell me what function this is?
Get,
What?
Get?
Get?
no way.
We've seen this pattern a few times now.
Interpret.
It's interpret instruction, right? We hopefully pattern recognition is kicking in here. We have this this wrapper here. We're ending with some value, and then based upon that value, we're calling some other function. Right? This is the pattern of interpret instruction. Now, what I'm interested in here is, let's find out what this function is. We'll double click a couple times. Please be something that's easy. It is. Does anyone know what this is?
Right.
It's the same pattern.
Right.
Right, we'll call it right register this time. Some people call it immediate.
The helper function is right register.
Okay. Some people call it immediate. We'll call it right register. Boom.
No, that one is.
I don't care. I'm calling this one right register today. I support you, sir.
It's a nested call.
I don't, we're doing it this way. All right. It doesn't need to be perfect. I just need to understand it. So I'm interested in this memory location. Whoa, how do I set a breakpoint right here?
Base plus 1
Great. I put my cursor here on the thing I'm interested in. We'll set a breakpoint at base plus 1b8d. If I am here, you can say commands. I think it's done. Calling right register. Now GDB is going to yell at me. I'm sure this is wrong. Is it done? Wow, I need to disable Jeff. It's not done. What's the magic word here? Can you remember? End? Is it end? GDB breakpoint command. Break commands. I had it right. End. Commands thing end. B8D, print F. Is it printing something or not?
You had it done.
Oh, there we go. Thank you. Cool. And so now my GDB script says calling right register. I'm out of time, but you could do things like if I knew that there was an important value, right? Let's say like register A is in RSI. I don't know that that's the case. This is completely made up. I can declare a variable here, read these values from memory, and then in my printf call, refer to those values. And so I can dynamically choose points of execution to have GDB grab things from memory and then output them. And so I can use this scriptable breakpoints to replicate the output of all of the registers, of all of the function calls, and just have it print everything out for me. If that makes more sense to you, do it that way. Right? If it was really easy and the easy one where I could just be like, oh, these are the things that I need, turn the hard one into the easy one. You can do that with GDB. But I am over on time, but I think I got close for 10 minutes. Any last minute questions before I end the stream? Yes.
So you can't do that with Jeff.
The question was, so you can't do that with Jeff. The answer is kind of, sort of. The problem, and this is not Jeff specific, there are problems that are Jeff specific, is the way that GDB does I/O is multi-threaded and they don't synchronize it well. And so what'll happen, we'll see if it happens here, is Jeff tries to write to the screen at the same time your print tries to write to the screen, and then you get nothing, right? And so Jeff ate my output because I was trying to print to the screen, and then Jeff said, hey, we're going to throw some stuff to the screen, and it is not happy. And so if you want to do a lot of heavy scripting, like a good rule of thumb is, disable Jeff. You can use Jeff to like look at things and inspect, but when you're actually trying to run your script and print stuff out, disable Jeff. Because otherwise, what you're printing and Jeff is outputting, well, they'll overwrite each other in a buffer and your output will be a mess. Any other questions? Nothing? Beautiful. And the stream, Rob will be probably late tomorrow. Goodbye, good luck. Let's make it happen.